awful lot about our work recently, and if you go to my blog, you can find a list of all of the papers. There's one that's very recent, just a couple days ago,
Yes, and that's
and the other,
Rose. That's Rose.blog, right? Or
yeah,
yeah.
it's a rose.blog. It's dwave.wordpress.com
Okay.
is the actual address. But if you search on rose.blog, you'll find it.
Okay.
The other thing is that we're going to try to make sure that the next time we do a demo in public, we can demo a system that's superior to conventional computer of roughly the same cost in terms of the time it takes to solve the problems that we're solving. So we're going to push the machine as far as we can until we get to the point where it's actually superior to its head-to-head competition, and then do the demo.
So you're basically saying
The
it would have to beat a current say mid-range supercomputer.
Yes, that's right.
Okay, so I get it from what you've said here and from your blog that the first demo that you did was just a standalone with your computer to do like the traveling salesman problem or image matching. I can't remember exactly what it was, but I remember after that, the physicist community did say, "Hey, where's your research? This isn't the way you do this. You know, we're not going to believe you." So I take it that's why you are now publishing through more academic circles.
No, I wouldn't say that. I think
Okay.
that the response of the academic community made something clear that wasn't so clear prior, and that's that the when you do something fundamentally different, that's very difficult to see the difference with your eyes, because computation is somehow an elusive thing when you think about what it really means to have a new model of computation.
Yeah, people it can't
You,
visualize it. Most people. Right?
yeah, you need to have, if somebody wants to answer the question, is this thing really a quantum computer? You have to be able to provide multiple angles of answer to that question that are independent from your own needs
You
or
know,
desires.
understanding. Yeah. Okay.
Yeah, so like if we may in our heart of hearts believe or know that the machines that we're building are quantum computers, which is the case, but there comes a point when that's not enough, and an external person who's considering buying one of these machines will ask rightly for independent third-party validation of these claims.
Aha. Right.
So the motivation for doing more peer-reviewed publication is still a commercial motivation, but it's taking to heart the understanding that when a potential customer is thinking about buying one of our machines, one of the sources that they're going to use to make that determination is whether or not the expert community is in agreement with the findings that we have. And the only way to do that is to take those findings and package them in the way that is done traditionally in science, and submit them for peer review.
Okay.
So the reasons for doing the peer review are not to become have everybody be our best friends, although that would be nice if that could happen. It's more about the short-circuiting the process to selling these machines at the highest prices we can to as many people as will want to buy them.
Right, and I suppose it's been a little difficult when you have someone like Scott Aronson saying that D-Wave is a red flag factory, and that I believe I read what in his blog or one of his articles, he claimed that the type of problems you're trying to solve with your adiabatic quantum computer aren't even solvable through quantum information science. I didn't quite. That's the first time I had ever heard that, and I just want to know if he's way off base there.
Well, so
he said.
Scott, I think that Scott's heart is in the right place, and I think that what he's trying to achieve is to try to embody something that Feynman said a while back, is that when you're scientists communicating your results, you want to be as certain as possible that you're communicating them in the most humble and pointing out all of the difficulties way as you can. And so I appreciate the angle that he takes on the communication of science, and I think that there is something to that.
Okay.
But in terms of the content of his criticisms, there really isn't any. There is an established set of algorithms for solving the type of optimization problem that we're solving, which are called adiabatic algorithms. And it's known that in certain cases they are better than any classical approach. And so what we're doing is we're building tools that will allow us to take problems that matter in the real world that have some optimization components, such as image matching, and boiling them down to the language of the hardware, allowing the hardware to run those problems, and then recasting the answers in the way that the application is demanding, so that the entire system is better than anything you can do classically. And all of that is based on ironclad science that anybody who knows this field is familiar with. So I think that the substance of his criticisms aren't so much about the science or the approach. It's more that he feels that there's
you're not doing
a
it
way
right.
that you
the
communicate results, and we're not doing it the way that he thinks is the right way to do it.
And he's a little upset about that.
Yeah,
okay.
But you know, the people have to understand, especially in the academic community, that they don't own science. You know, everybody who is working in science or technology has an equal right to push forward the boundaries, and we're doing it in a way that I believe is leading to progress in a way that no one else has been able to do. And we're, in my estimation, so far ahead of everyone else now in the construction of these machines that I think that it's going to be very hard for anybody to catch up to us.
Okay, yeah. And I would imagine that is so if you are still on pace, what you had mentioned last year. So I just want to, again, come back to that. You said that you are releasing information through peer-reviewed journals or through academia at this point. Is there any place we can go to look besides the blog about how many, I mean, I don't want to, I just want to simplify it here and get it down to how many bits do you have? Because it was last year that you had 16 or 28, I believe, somewhere in that. Or,
yeah, that's right.
Okay. And the projections were to be scaling now by this time of the year up to 512, and then eventually by the end of this year to 1024. And I was wondering, as far as bits are, can you say how far along you are at this point?
So we're on track with the schedule that we discussed earlier. I should say with the caveat that in terms of the tracking via peer review, the larger numbers of bits, none of that science has been released yet.
Okay.
So the only way that the larger number of bits machines have made their way into the public domain is through the demo we did at SCO7. Yeah. So those demos did not reveal any of the internal workings of the machine, although
people wanted that.
That will eventually be done. Yeah.
Oh, okay. Yeah, people wanted that at that time, but you're just holding back now. So,
well, not everybody wanted that.
Oh, not everyone, right? But I know there were some physicists that were demanding.
Right, but remember that the targets for us, the reason that we're around, is to sell machines to people who will use them to solve problems.
Right.
So our target audience is not the expert community directly. That is an audience for these things, but it's an audience that has a reason for being an audience. It's for
third party verification. Basically,
that's right.
That's what you're saying. Yeah, that is the communication with the academic community is primarily for third-party verification. Now, so okay, you're on pace. You say you're creating more bits, and eventually, now, I would imagine, especially once you get over 100 or 200 bits, that you should be able to clearly demonstrate. I mean, it should be just an oh wow, kind of demonstration where you beat a classical supercomputer with your 2, 3, 4, 500 bits that are supposedly going to be available at around this time of the year. Do you plan any public demonstrations or press releases at the point that you do that? Will there be any announcement?
You can be assured of the fact that when we're able to beat a conventional computer that costs roughly the same as what we want to sell these things for, we will
got a price on that?
Make it known.
You got a price on that?
Well, yeah,
What,
that hasn't been released publicly yet,
okay,
but you
that's
can
fine.
imagine.
I
The
can
systems
imagine
are,
it's multi-million.